Hello students, and welcome to the CompTIA Tech Plus exam course brought to you by Third Level Technology. I am your instructor, Jim Herbie. In this episode, we're going to continue in Module 5 in the exam objectives and discuss Section 5.3. Our topic is database structures. Let's begin. We will start our discussion by looking at the differences between structured and unstructured databases. A structured database is one that organizes all of the data contained within in a predefined format. We use a table format that uses rows and columns to organize our data in a readable format. The most common type of structured database is a relational database. These are databases that use SQL, the structured query language. SQL is the most common language we use to create relational databases that allow us to use data correlation to identify patterns between data in different tables. We organize our data through structures called schemas and keys, which we will discuss here in a moment. Schema will be all of the organizational backbones, such as your tables, fields, and columns. Keys are ways that we can identify specific attributes about a type of data. Let's contrast that with a non-structured database. A non-structured database are those that store the data within without a table format or identified fixed schema. Non-structured databases will not use SQL. We can use other ways to store data for items such as images, video files, email messages, and social media posts. Non-structured databases are very good for handling large volumes of diverse data. It allows us to identify pieces of data by file names, extensions, and other attributes without having to worry about the formal table structure within a structured database. A structured database has schema. Database schema is the structure and organization of your database. It will include all of your individual tables, fields, data types, and relationships amongst data. Your schema can be physical. This is the actual storage of the data contained within the database. We also have logical schema. This is a design view where we can use a software interface to identify the way we want to structure our database schema. One key component of our schema is a database table. Our tables are the way we organize and store our data in a grid format. A table will contain both rows and columns. Each row represents a single data point within the database. Your rows are uniquely identified, typically with a primary key. Your tables can be linked to identify correlations between data points and to establish relationships when we are doing data modeling of complex data sets. Within our database tables, we have fields and columns. Your columns are vertical displays of data, and each individual column is a field. A field is a specific attribute that allows us to identify data in a certain way. We can use specific data types, such as numerical, date and time, or text within each column. Within each column, all of the different individual records that appear will have the same data type. That is to ensure consistency across the database. We can establish relationships within our database structure with the use of keys. Your two most common are primary key and foreign key. Your primary key is a unique identifier that allows us to distinguish each individual record within a table. Some common primary keys could include your social security number, your date of birth, your last name. A foreign key is how we can establish our data relationships. A column or a field in one table that will be linked and displayed in a second table. And that second display is called the foreign key. Foreign keys allow a database table to pull individual fields from other databases into the table to establish relationships. It also helps to prevent any duplicate records that may occur because each record will have its unique identifier through its key. Another aspect of our database structure are constraints. Constraints are rules that we create within our database to prevent invalid data from being entered. We can use common commands such as not null, which requires a non-zero input, unique, which requires each record to be unique and individual, and foreign key, allowing us to identify when one field in one table becomes a part of a second table for correlation. Our constraints should be rules that apply across all data types. We want our constraints to be defined within our database table and schema, and to be automatically enforced by our database management systems. Another type of database is non-relational. A non-relational database is one that does not provide any data correlation. We will not store our data in traditional grid format with rows and columns. Instead, we use a flexible format depending on the type of data we are storing. One common non-relational database is a graph database. This is where we can store visual displays of our data. A document database will store data in text formats. We also can use key values. All of these are types of non-relational databases that we can use for both unstructured and semi-structured data. One common type of non-relational database is key value. Key value is data storage in a pair format. You will have a unique key assigned to each data point and its associated value. Keys will be displayed in some type of vertical or horizontal format that we can quickly retrieve by using input to identify specific key value pairs. It's a very simple, fast, and scalable database model. And lastly, we have document databases. These are non-relational databases that store data in document or text-based form. A document can contain key value pairs or have other flexible semi-structured data formats. Some common examples include MongoDB, CouchDB, and Amazon Document DB. The most common way that we format our document databases is with JSON, JSON, which is JavaScript Object Notation. That will conclude our discussion of Section 5.3 Database Structures. In our next episode, we'll move on to Section 5.4 in the objectives and discuss data backups. We thank you again for following along in the episodes and the course. Wish you best of luck in your studies. Enjoy the rest of your day.